Good day everyone, I am Malika Flores and our topic for this video is about the parts of the microscope. Microscope have been constructed in the 16th century. Microscope have revolutionized science with their ability to magnify small objects such as microbial cells, producing images with definitive structures that are identifiable and characterizable. So, what are microscope? Microscope are instruments that are used in science laboratories to visualize very minute objects such as cells, microorganisms, giving a contrasting image that is magnified. Microscope are made up of lenses for magnification, each with its own magnification powers. Depending on the type of lens, it will magnify the specimen according to its focal strength. Also, microscope are generally made up of structural parts for holding and supporting the microscope and its components and the optical parts which are used for magnification and viewing of their specimen images. So here are the three main structural parts of microscope, in that is the head, arm, and base. Head. This is the houses the optical parts in the upper part of microscope. Next is base. Base of the microscope supports the microscope and houses the illumination. And lastly, the arm. Arm connects to the base and support the microscope head. And next is, these are the optical parts of a microscope, and that is our eyepiece, eyepiece tube, objective lenses, nose piece, the adjustment knobs, stage, aperture, microscopic illuminator, condenser, diaphragm, condenser focus knob, Abbey condenser, and the rack stop. Number 1. Eyepiece is also known as the ocular. This is the part used to poke through the microscope. It's found at the top of the microscope. Its standard magnification is 10 times, with an optional eyepiece having magnifications from 5 times to 30 times. Second is the eyepiece tube. It's the eyepiece holder. It carries the eyepiece just above the objective lens. In some microscopes such as the binoculars, the eyepiece tube is flexible and can be rotated for maximum visualization for variance in distance. For monocular microscopes, they are non-flexible. Third is the objective lenses. These are the major lenses used for specimen visualization. They have a magnification power of 40 times to 100 times. There are about 1 to 4 objective lenses placed on one microscope, in that some are rear facing and others face forward. Each lens has its own magnification power. Fourth is the nose piece. This is also known as the revolving turret. It holds the objective lenses. It is movable, hence it can revolve the objective lenses depending on the magnification power of the lens. Fifth is the adjustment knobs. These are knobs that are used to focus the microscope. There are 2 types of adjustment knobs, and that is the adjustment knobs and coarse adjustment knobs. And sixth is the stage. This is the section on which the specimen is placed for viewing. They have stage clips that hold the specimen slides in place. The most common stage is a mechanical stage, which allows the control of the slides by moving the slides using the mechanical knobs on the stage instead of moving it manually. Seventh is the aperture. This is a hole on the microscope stage, through which the transmitted light from the source reaches the stage. And 8 is the microscopic illuminator. This is the microscope's light source, located at the base. It is used instead of a mirror. It captures light from an external source of a low voltage, of about 100 voltage. And 9th is the condenser. These are lenses that use to collect and focus light from the illuminator into the specimen. They are found under the sash next to the diaphragm of the microscope. They play a major role in ensuring clear, sharp images are produced with a high magnification of 400 times and above. The higher the magnification of the condenser, the more the image clarity. More sophisticated microscopes come with an Abbey condenser that has a high magnification of about 1000 times. And 10th, the diaphragm. It's also known as the iris. It's found under the stage of the microscope, and its primary role is to control the amount of light that reaches the specimen. It's an adjustable apparatus, hence controlling the light intensity and the size of the beam of light that gets to the specimen. For high-quality microscopes, the diaphragm comes attached with an ABI condenser, and combined they are able to control the light focus and light intensity that reaches the specimen. And next 11th, the condenser focus knob. This is a knob that moves the condenser up or down, thus controlling the focus of light on the specimen. And next 12th, the ABI condenser. This is a condenser specially designed on high-quality microscopes, which makes the condenser to be movable and allows very high magnification of above 400 times. High-quality microscopes normally have a high numerical aperture than objective lenses. And lastly, the rack stop. It controls how far the stages should go, preventing the objective lens from getting too close to the specimen slide, which may damage the specimen. It is responsible for preventing the specimen slide from coming too far up and hit the objective lens. And that's it for today. Once again, I am Malika Flores, third-year Bachelor of Secondary Education. Thank you for watching.